Hi, my name is mnadeau2, and this is my IMAP and DNS presentation for ISA 4220. Alright, this is the overview. We'll first be talking about IMAP and have a technical discussion on it, and then we'll have the best practices for the service, and then we'll move on to the DNS, talk about technical discussion, and then also the best practices for the service. Alright, so let's first start with IMAP and the technical discussion. So the first question is, what is IMAP? IMAP stands for Internet Message Access Protocol, and it's basically that. It's a set of rules that govern how messages are sent from a server to a client, um, email messages. So it allows uh, access to email on a local server. So it's kind of like POP3, so it's more on the receiving end and not on the sending end. It's established with the TCP IP connection, so as before, it does a three-way handshake and ensures that messages are being received on the other end. Also, its latest version as of now is version 4. It works off of port 143 for IMAP and then 993 for IMAP over SSL. It's abbreviated IMAPS. Also, all servers, most of like your Google or your Gmail, Yahoo use this on top of POP3. All right, next we're going to talk about IMAP in another technical discussion. This is how IMAP is different from POP3. Pretty much similar in the way that they both receive messages for email. The difference is POP3 will, once you make the TCP connection, will give you all the messages. It'll send them all over. With IMAP, it does it with headers. So the server sends you a header, makes a TCP connection, sends you all the headers. And then when you make the decision based off the header what message you want to read, you'll tell the server that you want that message, and then it will send you the rest of the message. Once you're done with it, you can either delete it or keep it, but it always stays stored on the server. I think that's my next point is storage. So with POP3 servers, it's not none of the information is stored on the server. So IMAP, all the information is stored on the server, and that's where you access it. So this could be a problem because servers can need a lot of storage space for these types of servers. Also, deletion. Deletion works with POP3 is it's deleted once it's sent. It's deleted from the server. With IMAP, the message isn't deleted until the user actually, or the client, tells the server to delete it. Message transmission. This is different. POP3, when it transmits the message, it sends all of them at the same time. And so, like, if you have message 1 is 5 gigs and message 3 is 3 gigs, and then you have a message 3 that is 512 megabytes. If you want to access 512 megabytes, you have to wait until the other message is downloaded before that message is downloaded. Now, IMAP is different. Like I said before, you choose what message it is by the header, and once you do that, that's what downloads. So, POP3 could be troublesome if you want to get to a message really quick and you can't because you have to download all the messages that are before that message. So next is accessible by multiple devices. POP3 you only can download it on one device. So what happens is you connect, you download from the server, the mail is stored on that device you downloaded from, and it's deleted from the server. So it's not reachable from the server from any other devices. But with IMAP, it's stored on the server. So let's say if I had a computer, I can go to the IMAP server, ask for message 3, it'll give me message 3, and then I can go to my iPhone and do the same thing and ask for message 3 and be able to read it. So it also gives messages for different states, meaning your red, sent emails. You're able to create folders. This is a good advantage of IMAP. POP3 does not offer this. Also, you have multiple folders. Actually, the states were, I said folders, but then you can have multiple folders where you can create the folders and drag and drop whatever email you want in there. So now we're going to talk about IMAP and the best practices for IMAP. First, you want to set up the SSL or TLS port 993 for IMAPs. This is so you can encrypt the data that is being received, and you can read it. And you encrypt data going to the server so no one can pick it up. Next, you want to educate your users on email usage. A lot of viruses come from users clicking on links, and a lot of spam comes in, and users give up some information or they contain a virus. So, proper education to the employees about email etiquette and how to spot spam and prevent it. Next is to prevent the spam with a SPF record. This record will prevent people to spoof their IPs. So your server already is blacklisting spam IPs. Well, the SPF will prevent those IPs from spoofing themselves and getting into your email server and creating a lot of spam. Next, you want to set a disk quota for all your employees, especially with the IMAP. You store every single message unless they hit delete, which a lot of employees don't hit delete. With POP3, you don't really have to worry about this, but IMAP, you want to set a disk space quota for each of the employees, usually around 5 gigs or so you don't fill up. So next thing on our list is the DNS. We're going to have a technical discussion on it. But first of all, we have to know, what is a DNS? A DNS is short for Dynamic Naming System. So what it actually does is it makes it easier for us as users to go to a server online. As you know, servers' names are really IP addresses. That is how the computer processes it. But us as humans, we remember names a lot better than IP addresses. So what the DNS does is, let's say you want to go to google.com, the DNS, you'll send the request to the DNS. The DNS will look up google.com, and then in the table it will show an IP address, and then it'll send the IP address to your computer or your whatever you're using, and then you'll go to google.com. So as you can, it's a dynamic naming system. It works off of domain names and host names. So domain names is like .com, Yahoo, .net, and yes, so Yahoo.com is actually two separate domain names. Also, you have the host names. This is more of like the computer or the machine you're using itself. So my computer, for example, local computer, or like default name. So the DNS, when you talk to the DNS, usually it's over port 53. It's recommended to open both the port 53 for TCP and UDP connection, but it's better to use TCP connection just so you know that the request is getting received on the other end. Next is your DNS IP address. You can actually figure this out so you know where your DNS resides. If you in Windows, if you type in ipconfig/all on the diagram on the right, about in the middle, you can see it says DNS servers, and it gives 2 IP addresses. It's possible to have 2 or more, or even 1 DNS. Usually you have a primary and a secondary. You're both going to have primaries, but so the primary usually is for the zone data, and it can actually communicate this with other servers, which is called a zone transfer. And then the secondary is just a slave. So it just receives data from the primary server automatically. So your DNS is a part of a huge database with a, a lot of there's thousands upon thousands of other DNSs, but there's only 13, they're called root databases. They're the third. And now we're going to discuss DNS and the best practices. So one thing you can do is you can use a secondary server for your zones. This is to offload the the query data. So when the someone makes a request, the cache goes into these servers. So these can be used to as a backup server in the case DNS can't reach the primary server, and also it can be used for legacy DNS clients. Next, you want to ensure you follow basic guidelines. There are guidelines that are out there that discuss on how you should set up a DNS network and the preferred practices for managing it. Make sure you follow these guidelines specifically. Next is you want to configure the correct administrator's email in the DNS notifications setting, meaning when something goes wrong with the DNS, this setting will send an email to whatever email address you have in there. So ensure that whoever is your administrator for that for the DNS, make sure that their correct email is in this field where they won't get any warnings. Next, you want to host a backup server for each zone. This is just for redundancy. So if your DNS goes down, they can still get their PTR resource records. This is to stop the spam, because if your DNS is not available or reliable, they will not get the proper PTR resource records, and you'll start getting a lot of spam coming in. So that's it on my presentation. I hope you enjoyed.